All right, today, guys, we are going to use equivalent fractions to compare. Okay? So, we're going to compare fractions by writing an equivalent fraction. So, this is going to make much better sense for some of you than our other strategies. So, raise your hand. What do you notice? What do you wonder? Brayden.
That number 2 isn't correct.
This one?
Yeah.
So you think it's false? Ah,
I mean, it's equal.
Oh, it's equal.
Yeah.
Okay, I agree. Minna, what do you notice?
That there's a 4 in front of the 1/2.
There's a 4 in front of the 1/2, so we have a mixed number, don't we? Yeah. River.
I noticed that the third one isn't true because 3 halves would only be 1 1/2, but 4 is 8.
So it would be 8 halves, right? To make 4. Good job. So 4 is actually greater than 3 halves, isn't it? Okay, great.
The first one is the only one that isn't a fraction, or doesn't have a fraction.
Not a fraction. Is it true? Is 8 greater than 5?
Yes.
What about this one? Is 1/3 less than 1/2?
Yeah.
No. Yes.
So let's think about the size of our pieces. If I have a pizza and I split it in half, is that piece bigger than if I split my pizza into 3 pieces? Yes. So this one's actually true. So remember, if your numerators are the same, look at your denominators. Okay, Trey.
Or you could do it a different way.
What's that?
So if you just count how much it takes to get the 1 whole, and it's more because the 1/3 takes more to get to 3/3, but then the 1/2, the 1/2, or whatever it's called, takes 1 more to get to the whole.
Yes. Very good. I like that. All right. Mark your spot with your pencil. And let's go ahead and we're going to talk about it. We're going to talk about activity 1. So we're going to have some groups of fractions. And these are some fractions that we sorted yesterday. So they should be familiar. You guys remember the chart we did? I know you weren't here, Mia, but we'll catch you up. So we compared them to 1/2 and 1 whole. So we're going to look at group 3. What do the fractions in group 3 have in common? Why do you guys think they are in the same group? What do you think, Alice?
Because the first 2, these 2, the numerator is 11, these 2, 26 is 8.
Okay, so we have the same numerator on this side, same numerator on this side. Do you notice anything about the denominators? Grace, what do you notice?
The degree that 3 is, 12 is a multiple of 3, and 10 is a multiple of 5.
Wow, I owe you a magic ticket. Did you guys notice that?
Yeah.
If we look at those denominators, 12 is a multiple of 3, and 10 is a multiple of 5. Okay, how are the fractions in group 1 different than the fractions in group 2? What do you notice? Are they the same?
No. Well,
What is the first thing that stands out to you? What's the first thing, Tallulah?
That there's some numbers that's not in group 2.
Like which number?
111.
So did you guys notice these big denominators over here? So group 1 has 100 and group 2 does not. And then Tallulah also pointed out 11 is not in group 2. Okay, River, what do you notice?
I noticed that 3 and 12 from the bottom moves to the top, and 5 and 10 from there move to the bottom of group 2.
Yeah.
And also 100 is a multiple of 5, and 100 is also a multiple of 10.
Oh, how interesting. Yeah. Okay, so we can tell that the fractions in group 2 are greater than those in group 1, and the fractions in group 3 are greater than those in the other groups. And you guys kind of just compared the fractions in each group, didn't you?
Yeah.
Yeah. Okay. So here's what you're going to do. Here are some pairs of fractions sorted into 3 groups. You're going to circle the greater fraction in each pair, kind of like your cool down yesterday. And you're going to explain or show your reasoning. Guys, you're going to go with your partner, and then we're going to come back and we'll synthesize in 10 minutes, okay? All right, so you guys have had a couple of minutes to work with a partner and talk about these. Now, I want to show you guys how to make an equivalent fraction to compare these fractions. So everything I write on my paper, I want you to write on your paper. So we're going to look at problem A. So we have 2/10 that we're comparing to 26 hundredths. So the first thing I do is I rewrite the 2 fractions vertically. So do that on your paper. Okay, then I make equivalent fractions so I can easily compare. So I'm going to look at the denominators. We have a 10 and 100. What number do both of those go into evenly? Maddie. 200, we could do 200. I bet you know a smaller number though. Minna?
50?
100 doesn't go into 50 because 50 is smaller than 100. Tucker?
300?
Yeah, that could work. One more. Alice?
110?
110 would work. How about we just use 100? Does 100 go into 100 evenly?
Yes.
Yeah. We're going to keep it simple. So we're going to give both of our new fractions the same new denominator. Then, are you writing this down, boys?
Yeah.
You're going to make new fractions. So I'm going to think to myself, 10 times what number is 100? What is it? Just say it.
10.
Oh. What you do to the bottom, you do to the top. So if I multiply my denominator by 10, Then I multiply my numerator by 10. So what is 2 times 10, everybody? 20. Now look down below. 100 times what is 100? 1. Right? What you do to the bottom, you do to the top. What's 26 times 1? So I basically made the same fraction, but now I'm comparing 20 hundredths to 26 hundredths. Which is greater, 26 hundredths or 20 hundredths?
26.
Raise your hand if you think 20 hundredths. Raise your hand if you think 26 hundredths. Okay, good. So it's 26 hundredths. So I would make my alligator sign or piranha. So his mouth is facing the bigger fraction. Okay, so this little strategy is called making equivalent fractions, and then we can compare. Okay, let's do problem A in group 2. Okay, and you guys are doing it with me. So first, I rewrite my fractions vertically. So right there on your paper, are you with me, Tucker? I'm going to write 2/3, and I'm going to write 7/12. And then I'm going to make equivalent fractions. So I'm going to look at my denominators, and I'm going to think, what number does both 3 and 12 go into evenly? Do you know what it is?
4.
No, 4 is smaller than 12. So it has to be 12 or greater. George, what are you thinking?
Oh, I'm just stretching.
Oh, you're just stretching. Do you want to try? Okay. Trevor?
24.
They both go into 24. Can you think of a smaller number, though? We could use 24. That would work. Landon, what are you thinking? Oh, 12 doesn't go into 18 evenly. What are you thinking, Isla?
12.
Hey, how about we use 12?
Yes.
What do you guys think of that? 3 goes into 12. Does 12 go into 12? Okay, so I'm going to make 12 the denominator of both of my new fractions. Now, I say, okay, 3 times what number is 12? 3 times what, guys? 4. What you do to the bottom, you do to the top. So what is 2 times 4? 8. Very good. Okay, then down below, 12 times what is 12? 1. Which do to the bottom, you do to the top. Minna, are you writing this down? 7 times 1 is? 7. So this fraction stays the same. Now, which is greater, 8/12 or 7/12? Everybody. 8/12. So 8/12 is greater, but we're comparing 2/3. So 8/12 is equivalent to 2/3. So 2/3 is greater. So you would make your alligator mouth facing, you're going to make his mouth open facing that 2/3. Is this making sense? Yeah. Okay. All right, so this is our strategy. The book thought you guys would just figure that out on your own. But I think you needed a little teacher help, huh? That's okay. All right, now activity 2. So mark your spot with your pencil. Okay. Activity 2. Look up here. You have, for problem 1, you have 4 fractions. You're going to decide if each statement is true or false. I want you to decide using our new strategy. So like for A, you would sit with your partner and you're going to rewrite it vertically, and you're going to make your equivalent fractions. After you make your equivalent fractions, then you can decide, hey, are these fractions actually equal, or is one greater? Nina?
Could you use the butterfly method just to recheck your work?
If you do this first and I see all of your math, okay? Okay. Any other questions? Okay, so we're going to go try this with our partners. Oh, wait, is there only one problem or is there two? There is two. So for problem 2, we're getting a little bit harder. And for this one, you're actually going to decide and write greater than, less than, or equal, if you have time. Okay? All right. Find your partner, find a place to work. So we're looking at question 2 for activity 2. And I want to look at, let's just look at B right here. So does everybody have their book open? Page, what are we on to? 50?
58.
58 has this one on it? Okay. Okay, so the first thing we're going to do is rewrite them vertically. So if you already did it, you're checking your work. If you didn't do it, you should have a pencil in your hand and you should be doing it. So we're going to rewrite 4/3 and 7/6 vertically. Then we're going to look at our denominators. What number does 3 and 6 go into evenly? What number goes into 3 and 6? Or what number does 3 and 6 go into evenly? Okay. Yeah, Annie? We could do 12. 12 would work. There might be an easier, smaller number that would work. Mia?
6.
Yeah, hey guys, let's just use 6. Don't you think that would be easier? Okay, so we're going to make our equivalent fractions with a denominator of 6. And then we're going to start here and we're going to say, okay, 3 times what number is 6, everybody? 3 times 2 is 6, right? So what you do to the bottom, you do to the
Top.
Okay, what is 4 times 2?
8.
8. And then our bottom fraction, 6 times what number is 6?
1.
1. What you do to the bottom, you do to the?
Top.
What's 7 times 1?
7.
Okay, now we're comparing 8/6 to 7/6. Which one is greater? Isla? 8/6. So 8/6 is the same as 4/3, right? So then I come to my original problem and I'm going to draw my alligator mouth pointing towards 4/3 because that is our greater fraction. Okay, this was our first day of doing this, guys. We will continue practicing this the rest of the week, but let's look at our cool down before I send you off. So our cool down has 2 questions. So if you're showing your thinking, I should see your fractions rewritten vertically, and I should see those equivalent fractions, right? There's my hint for problem 1. Can you find a number that both 8 and 4 goes into? Okay, don't tell me. Can you think of a number 5 and 100 both go into? 100, right? That's my hint. You still have to do some math to figure it out, Weston. Okay. Guys, we're going to do our cool down.